All right. So I think at this point maybe I'll get started. I mean the intro, I mean I've got some slides here, but it's all kind of more intro information so people can keep coming in and can kind of it'll take a couple of minutes before we jump right in. So my name is Gabriel Selzer. I am a software engineer at Ellisiri Lab, maybe better known as LOSI, at the University of Wisconsin-Madison. And today I'm going to be talking and kind of covering the basics of how you can take the Fiji application, which has been around for a long time, and integrate it with Python. Um, this integration has only been around for a little while. So these slides here are kind of introductory, just kind of talking about why you might be interested in this. And then we'll kind of get into the actual kind of interactive hands-on workshop part. And you can join if you can kind of follow along if you would like to. So this is kind of what I just said here, this kind of introductory slides. And then these are the kind of hands-on steps. And I've got a document which I've got linked. You can follow along. I'll hop over to that document once I finish up with these couple of slides and we can kind of go through that together. And if people have questions, feel free to type in the chat. Send us the slides. Yes, there will be a link and like 3 slides, and you can hop over there. The slides will be there. There's only like 5 of them. And then the workshop document's also there. And so you can just download the document. Yes, hopefully that'll become clear in a couple of slides, but don't worry, we're getting to it. So yeah, so maybe broad overview as people are still coming in. This workshop is really trying to unify 2 different tools. And the first tool is a tool called Fiji, which has been around a long time. There were 2 workshops done by Helen and Ed, who are my colleagues. Kind of about why Fiji is cool. Fiji is really a combination of a couple of different applications, one of which is the original ImageJ application, which has been developed for over 20 years now by Wayne Rasband, who was at the time at NAH. And so it also includes ImageJ2, which is developed at LOSI by Curtis Rueden, among many others. And ImageJ2 tried to modernize and improve the architecture over ImageJ, over the original ImageJ, and included imblib2, which really provided a modernized data structure that was able to handle many more situations than the original ImageJ data structures. It also included the side Java library, which modernized the plugin architecture. And then it finally includes this ImageJ legacy library, which links the 2 together so they can talk to each other. And Fiji bundles all of these things up. It bundles the original ImageJ, it bundles ImageJ2, and also bundles all of these plugins like bioformats and TrackMate and SNT and many, many more. So Fiji has all of this functionality, which has been developed for decades, really established application. So that's like the first application we're talking about today. And the second one is this monolith of Python. Python nowadays has, tons and tons of libraries written for it. It's really great for scientific computing. All of the scientific applications are built atop the scientific stack, virtually all of them. In particular, they're built on top of NumPy, which provides the ND array structure, which everything uses. And then you have some kind of foundational algorithms libraries like scikit-image and SciPy. And along with these things, you have all of these great machine learning toolkits like TensorFlow and PyTorch and scikit-learn. And now we're starting to see a lot of kind of end user applications where you can kind of use all of these things in a friendly interface. So you have Napari, and you have CellPose, and you have CellProfiler, and there are many more, right? So Python's becoming this really attractive environment to do scientific computing. But at the same time, Fiji is still there. Fiji is still great. Fiji has a lot of things that can't be found elsewhere. And so we kind of then come up with this question of how can we still use some of these really great features of Fiji while still kind of migrating to this new super cool Python ecosystem. And so that's kind of what I want to talk about today, is how we can maybe get the best of both worlds and unify these 2 things together, because Fiji is built on top of the JVM. The JVM is a separate technology from Python, and it takes a little bit of work to get these things to play nicely together. So Yeah, that's mostly all from my slides. And so now we can hop over. Oh yeah, I guess to give a little bit of an overview of what the goals are. This markdown document, which will be kind of up in a couple of clicks here, it has 3 different steps. The first step is kind of like explaining how Python and Java could talk if you're trying to, like, once we start to integrate these things together. And then there's a couple of steps outlining the PyImageJ technology, which is kind of how you end up using Fiji from Python. And then there's the Napari ImageJ technology, and the final steps are about that. And Napari ImageJ it's a plugin for Napari, as it says in the name, and its goal is to provide you a nice Pythonic user interface that you can use to access everything from Fiji. And so, yeah, so we can now look at this document. You can go to this workshops.imagej.net. So I will hop over here. And I'm going to paste this into the chat for everybody asking. Say right there. So that is the link to the document. And so the slides are fine, and you can always, if I move too fast, feel free to ask questions. But if I move too fast, you can always come back to this document. The slides are here as well. But really, my preferred way to view this thing is by clicking this "Find Me on GitHub" banner. Over here on workshops.imagej.net, you click Find Me on GitHub, and then you come down and find this Fiji Python 2024.md. This is the document. So you click this guy, and then now you have this thing nicely rendered. So you can see all the images and the headers display nicely. So you have rendered Markdown. So this is great. And I guess if there are no other questions, if I'm assuming hoping people were able to find this document. So if there are no other questions, I'll kind of get started with step 1 here. Yeah, wait a second. Can you send the GitHub link? I can send, yeah, I'll paste the link directly to the Markdown document there. But yeah, like if you want to access this again, the easiest way is to go to workshops.imagej.net and you click Find Me on GitHub here. Increase the font size. I can do that as well, I think. Hopefully GitHub allows that. But yeah, and then you come over here. So let's see if this increases the font size. Yeah, it does. Great. Okay, great. So I will get started with maybe this environment setup. So like I said, I mean, when we're integrating Fiji and Python, we're really integrating Java and Python. And so we have to take a couple of steps to actually set up an environment where they can talk to each other. And really the way that is done is by copying this one line and creating a Mamba environment. So in the pre-workshop instructions, I had suggested that you followed the Napari ImageJ installation instructions. Installing Napari ImageJ is basically just doing the same thing. But it requires that you have Mamba installed or Conda if you want things to be slow. So if you have Mamba installed, then you should just be able to take this little one-liner and copy it into the terminal of your choice, and press enter, and it'll download. And so then this will download a couple of different things. It'll download PyImageJ, which is kind of that integration layer between Fiji, ImageJ, and Python. So that's actually what's going to be talking to ImageJ. Well, it's going to spin up an ImageJ instance for you, actually. It'll download Python for you. It'll download Java 8, which is, Fiji's built on top of Java 8, so you'll need that as well. But it'll also download Napari, and it'll download Napari ImageJ for us, which will help in the later steps. So this thing will take a minute. I have all of these things cached, so yep. So, I'll just say, yes, I want to install all of these things, and then all of these libraries will install. And then once that's done, so Mamba will have created this environment for us, and then all we have to do is say Mamba activate Napari ImageJ. Napari ImageJ is the environment name that I assigned that I store all of these libraries into. And so we can just click Mamba, or we can type this in, copy this. And then we'll be kind of ready to go. So that's kind of environment setup. I hope we tried to make it as painless as possible, but so hopefully that's not an issue for people to kind of, hopefully people don't have issues running this code. Oops, I copied the $. I'll copy that code, paste it in, and now I'm ready to go. So if there are no other questions for that, we can kind of get into like how we actually, move on to step 2 and talk about how we actually initialize ImageJ, and that we can start to get stuff working there. So maybe I'll wait a couple of seconds here for questions. Okay. Well, I'll keep watching the Zoom chat, but we can move on. The last step here is that for this workshop, it's kind of nice to have everything installed and like localized to a single folder. So I'm going to create this folder, and then I'm actually going to open it with Visual Studio Code, which is totally not a requirement for this workshop, but it is kind of nice for me to be able to like show you a terminal and multiple files in a single location. So I'm going to open that. So I'm going to this folder, and then I'm going to open it in VS Code. Okay, so it opened on my other screen, so I will pull that over. Okay, great. So I now have this folder, Fiji Python 2024. And to kind of make sure that Fiji installed correctly, I'm going to create a Python file, which is just going to let me save a couple of lines of Python code. I'm going to call it step2.py because we're in step 2. And then I'm going to copy these 3 lines here. These 3 lines, I'm going to copy it, and then I'm going to run it. I'm going to talk about it while it boots up. So I'm going to grab these 3 things, and I will make this text bigger as well. Make these lines a bit bigger. And I'm going to add a terminal so I can run these lines. Great. And it's gone. Okay, so now I can run this guy. And so what's going to happen here is that there are 3 lines of Python that we're going to run here. This first line is going to import ImageJ, which it's just a standard Python module. So we import ImageJ. The second line here is going to initialize an ImageJ2 instance for us. And this can be configured, and I'll talk about that in a minute. But right now, we're just going to get a stock ImageJ2. We're going to download the latest ImageJ2 off the internet and install it. And then the third line here is just kind of a sanity check, making sure that everything worked correctly, and it's going to print out the version of ImageJ2 that we have. And so you can see at the bottom that this thing ran. The line is out here here at the bottom. It says successfully initialized ImageJ, and then here's our ImageJ version, which is 2.16.0. And the slash at the end is for the original ImageJ, because the original ImageJ is kind of part of this ImageJ2 distribution. So we also have this version of the original ImageJ. So that's great. So this all ran, and I can see that I got the same output that I was expected to get. And so this, like I said, this is just downloading an original ImageJ. Like it's just downloading ImageJ2. If you want Fiji, you can use this option instead, which we'll use for this workshop. All I'm doing here is specifying in the constructor call to imagej.init. I'm just specifying that I want a Fiji, and I want the Fiji of this particular version. I want this particular version of Fiji. So if I take this code and I copy it, and I replace what I have here in step 2, I can then run this guy. Let's run this again a second time. And you can see that now I have Fiji, and then my version of Fiji, like of ImageJ2, was actually downgraded, right? Because I specified here that I want version 2.15. So now I actually got Fiji version 2.15. So adding in like an actual version of Fiji can be helpful because it ensures that your scripts are reproducible. So later on, when somebody downloads this your script and they try to run this Python script, they'll get the same version of Fiji that you used, and everything will work in the same way that it worked for you. So in terms of reproducibility, it's very nice to pass this type of thing through. And there are a ton of different options that you can use to initialize your ImageJ. Those are all listed on pi.imagej.net. So it's this website here, pi.imagej.net. If you go here and you go to initialization, you can see that there are a ton of different options. I'm sorry, this text is probably pretty small. There are a ton of different options here for how you can specify your version of ImageJ, and this is all kind of towards the goal of making things reproducible so that people can run this same code that you wrote later and it'll all work the same way it worked for you. Yeah, so that's initializing an ImageJ, and like now I have this ImageJ instance. I can basically do whatever I want with it. I can access anything that I could access on the Java side, and the next steps will kind of go into that. And we'll be able to actually do some things. So let me pull back up the Markdown document. Does anybody have any questions on step 2 here, like actually getting an ImageJ instance loaded up in Python? I'll stop for a couple of seconds before I jump into step 3 here. Okay. Well, I will continue to watch the chat, but I think I'll try to get into step 3. And this is kind of an important step because you're going to run into this whenever you try to use PyImageJ. And this is the issue of kind of making PyImageJ or making ImageJ, making Fiji understand your data. Because we're working in Python, and if we're using PyImageJ or Fiji or if we're using these if we're using Fiji with any other Python application, we're probably going to be using NumPy arrays, right? That's kind of the lingua franca of Python. But the problem is that Fiji has never heard of an ND array. It has no idea what that is. It doesn't know how to use it, and so we fundamentally kind of have this disconnect between ImageJ, Fiji, and all of these Python tooling. And so one of the biggest utilities of PyImageJ is being able to translate your data, being able to translate your NumPy arrays into things that Fiji can understand, into the net.imagej.data sets or the IMGs, or all of the IMG plus or image pluses from the original ImageJ. You have all of these Java data structures, being able to translate from an ND array into those things, and then being able to translate from those things back into an ND array or something else like it that all of our Python tools can understand. So step 3 is kind of all about that. And the first step, I'm going to construct, as an example, a script that will take an ND array that I loaded up with scikit-image. I'm going to do just a Gaussian blur and with Fiji, just to kind of like, as kind of an example. And then I'm going to translate that thing back into Python to view it with napari. So this is like, a super basic workflow that you could maybe later take and then kind of update or alter to fit your needs. The first step is this kind of taking this script here. The script does a couple of things, and I'm going to make a new file in VS Code here and kind of walk you through it. So I'm going to make a step3.py file. I'm going to paste this code in. And this code, it starts out by doing the same thing that we did in step 2, where we created an ImageJ instance. We passed through our particular Fiji version that we wanted, and creating an ImageJ instance from it. So that's the same as step 2. And then the next thing that we do here is we read in this particular data set with scikit-image. So I'm using scikit-image.io. This thing is going to be a NumPy array. And actually, I'm going to run this thing. I'm going to run this thing interactively so we can actually kind of look at what's going on here. So you could run this in the same way. I think the Markdown document, it can tell you just to run Python step3.py, this will work. but I'm going to run it interactively so we can see that here, we've got our ImageJ instance. This thing is just a net.imagej.imagej. And I can, then I can have a Python. I'll have an ND array here. And we can look at this P image guy. It's some ND array. Yeah, it's got it's three-dimensional. It's got 61 z-planes, and yeah. So we got this three-dimensional ND array, and we want to do something in Fiji with it. So the glue that PyImageJ provides to kind of tie these things together to do the translation it is really encapsulated within this function here. You type ij.py.toJava, and then you pass through your Python thing, and then the output will be a Java thing. So if I do use this call here, you'll see that now I have a JM here, and I can say jm.shape. This is a nice little piece of syntactic sugar that says that, now it's the same thing. The dimensions have been reordered, and there's an addendum in the markdown file about this, but it's the same thing, but now it's converted to Java. It's now one of these ImageJ things, and now I can do ImageJ things with it, right? So here I do a Gaussian blur. I can run this thing. It runs just fine. Then I had a little print statement at the end of this script just to say like, hey, this thing worked. And you'll see out here that, you get out this array, which is a Java construct, which is just fine. So we were able to call this Java thing on an image that we originally got from Python, which is great. But, luckily that's not the end of things. And in a lot of cases, then you need to take that ImageJ thing and put it back into Python, and translate it back into Python so that you can do something else with it in the Python world. And this script does that. So this script starts, let me copy this script in. So I'm gonna basically replace this script here. So this script, it does almost exactly, it starts out exactly the same, where I initialize my ImageJ, read in my image. Up to here, it's exactly the same as it was before. We converted this thing to Java. We did a Gaussian blur using ImageJ ops from Fiji. The only thing that's different here are these last two lines here, where I can run this guy. And it'll get down here, and I'll let it run until we hit this method. This method is the counterpart to ij.py.toJava. It's just ij.py.fromJava, and like the name says, it takes something in Python or in Java, and it converts it back to Python. So we have this Java image, this JGauss thing, which was the output of the Gaussian blur. It's an array from M2 from Fiji. And I call ij.py.fromJava, pass it as an argument. I come out with this pgauss thing. This pgauss thing is another NumPy array. And I can, then pass it to napari and view it just like I would any other ND array. And so this thing should start up in a napari viewer. I might have some problems because I ran it in this debugger from VS Code. But theoretically, it should start up. Oh, there it is. Yeah, so there's my Gaussian blur. Obviously, it's a very blurry version of the original data set. But I could, maybe say viewer.add image, then pass through the original thing, which was, I think, this Python image. Yeah, pimg. So I could pass that thing through. So we could compare it. And, you can not just take me at my word that I'm not just working with a blurry data set. But yeah, so this thing will run, and then we'll see both the original image and the image that was blurred using ImageJ, both in one napari viewer. So this script provides kind of an example of how you can, do the data transfer. You can convert a Python image into Java. You can do ImageJ things with it. You can convert it back to Python, and then you can do more Python things with it. And you can kind of chain these different translations together as needed to create a workflow that uses Fiji things in tandem with something from scikit-image, or maybe you have a TensorFlow model that you want to do Fiji preprocessing with, or you want to preprocess your data with Fiji before you pass it in to your model. Yeah, so here's the original image. There's the Gaussian blur. We're going to work with this data set throughout this workshop. So you'll probably become pretty familiar with kind of seeing the shape. But yeah, so there's the Gaussian blur. It's kind of like basic Fiji usage. Does anybody have any questions on this step before I move on to step 4? Wait another couple of seconds. I'll close my viewer. Okay, yeah, I'll keep watching the chat. But we can move on to step 4. And this is kind of a natural, I don't know how many of you were able to attend Ed's talk yesterday on scripting, but this is kind of a natural follow-up to scripting in Fiji. Because if you've worked with Fiji any amount, hopefully you tried to automate that work to make it easier later on, and you've written some of these side JavaScripts. And I wanted to highlight PyImageJ's ability to just run these scripts because it's really powerful, right? You can write one script in Fiji, and now using PyImageJ, you can just run it in Python. And so it's a real testament to making things portable, because now you could, run it in Python or in Fiji. And, if you need to migrate your workflow to Python, then you don't have to rewrite a large chunk of your workflow. So I think that's quite nice. So step 4 is kind of about how we can run a script that we've generated, that we've written in Fiji using PyImageJ. So I've got the script here. The script was given to me by Ed, who I think was on the call, which does Richardson-Lucy deconvolution, which he talked a bit about yesterday. It's something that ImageJ ops, which is a part of Fiji, it does really well. And so it's kind of a natural candidate of like, this thing is great, and we might want to use PyImageJ so we can access these nice deconvolution utilities. So I'm going to copy this script, and I'm going to throw it into using these directions into a particular location. So the Markdown document tells me to create a folder that is named scripts within the current directory. So I'm going to do that. And the reasons for why we're doing this will become apparent later. But right now, we just make this this folder scripts. And then inside of that scripts folder, I'm going to create a new file. It's called decon.groovy because we're doing deconvolution, and the script is written in Groovy. So I call it decon.groovy. And then I paste code in. So here is our script. So that looks great. And then I'm going to create a new Python file that contains this code here. This is step 4. I'll paste this code in. And I'll run this code again interactively, and you're going to start to see a lot of similarities to the previous files because, right, the goal is to kind of build up kind of knowledge of how this works. So I'm going to run this code interactively. And you'll see that it starts out the same way that step 2 and step 3 started out, by creating our ImageJ instance. And then just like in step 3, I'm going to read in the same data set. And now to run the script, we need 2 things. We first need the script itself. So I'm going to add these 2 lines here, read in the script into a Python string. So if I come down here and I print out this script variable that I just created, you can see here's that same script. Just load it into a Python string. And then the second thing that we need to do is we need to tell PyImageJ what the arguments are to the script. So you'll see that the script, it takes an image right here. This is a Java image. And then it takes a ton of optional parameters that are kind of hyperparameters for the deconvolution, right? So there are, they're parameters for the deconvolution. And they all have default values. So we don't actually need to specify all of these things when we actually call it here in this file. So the only thing that I really need to do is specify the input image. And I put it in this dictionary. You'll notice that this img keyword here for the dictionary is the same thing as the argument name on the script, right? So I'm just assigning my image that I read in from scikit-image to this img parameter name. And then I come down here and I can use this functionality, ij.py.run script, and this will run the script. And this will actually take a couple of minutes because deconvolution can take a little while and I didn't change the parameter. So I can talk about some of these other things while it runs. So in addition, if you're somebody who uses ImageJ macros, there is kind of like a sister function that's ij.py.run macro, and that can run ImageJ1 macros. And I haven't used it before because I'm not super familiar with the original ImageJ, but I know it exists, and so it should run in the exact same way. And there's also a second one, there's a third one called ij.py.run plugin, which runs it runs ImageJ plugins. I fairly certain it runs ImageJ2 plugins and might also run original ImageJ plugins. So these things, those three functions should be able to cover almost the entirety of what you might be able to automate in Fiji, right? Running macros, running scripts, and running plugins. And so you can see that this thing finished. Now the output is a Java thing, right? This result map, this result from the Groovy script it's a Java thing. So we have to convert it back to Python, which we now know how to do. So I do that with this line. And then just like in step 3, I'm going to view these things with napari. But you might have some other Python utilities you want to call here, and you could just kind of paste those in. So I'm going to skip over these last couple of lines and start up the napari viewer so that you can see that our image deconvolution ran. Once the napari viewer boots up, there we go. So yeah, here's the original, and here's the results. You can see that using deconvolution, we kind of remove some of this background noise. As compared to the original, you also see some structures that are inside of this particular cell in this data set that are maybe a little more visible. So there is deconvolution using Fiji. So that is step 4. I think that was the end of step 4. Yes. So does anybody have any questions on kind of being able to run scripts, being able to run macros? I'll wait a couple of seconds before I move on. If anybody has questions about like how do I write scripts for SciJava scripts, writing scripts in Fiji, I'd advise you go to look up Ed's talk from yesterday because he talked about how to write scripts. In addition, I think I linked in this document. Yeah, I linked this guide by Albert Cardona, who is like one of the founders of Fiji. And it's a really kind of in-depth guide to SciJava scripting, and now it applies to both Python and Fiji. So it's a good read. Definitely too in-depth to cover here. Great. Okay. Well, in that case, we can move on to step 5. So in the previous steps 2 through 4, we kind of just covered basic Python ImageJ usage. This kind of covers everything that you can do just from a script, which in itself is very powerful. But sometimes you just want that GUI. And in this case, we've also developed the napari ImageJ plugin, which will provide you basically all of the functionality that we just described through a user interface. So step 5 is just kind of about launching the napari ImageJ plugin, which is already installed based on our environment setup earlier. And so all you have to do to get this thing running, I'm actually going to switch back over now to my console. And so you can just start up napari. And once napari is running, you can access napari ImageJ like it shows in this GIF, where you click on the plugins window, and then you find the napari ImageJ plugin in the dropdown. This is the old viewer. Okay, and this is the new viewer. So in this one, you can see I just click on this plugins tab. Down to ImageJ2, I click it, and then this will boot up napari ImageJ, which is this pane here. And you can see that it took a little while for napari ImageJ to start up. It said initializing ImageJ2, please wait. And it's just kind of letting you know, like, hey, we're booting up the Java virtual machine, we're starting up Fiji. And once that completes, then you'll see all of these buttons kind of light up, which means that it's ready for usage. So that's kind of how you get napari ImageJ started up within napari. Just install it with pip or conda, preferably with conda, because then it allows you to bring in the JVM, and then you can start it when you have napari open. So step 5 and 6 are kind of basically the same thing as these earlier steps. And so I'm just going to kind of show you how you can do basically the same thing we did here, where we just called a Gaussian blur on some data with napari ImageJ. So to do this, you'll need some data, and I'm going to download that data set that we were seeing earlier using this link here. So I'll open this guy, I downloaded this guy. It's now in my downloads. So I can open it right here. So here's that file. I'm going to open it, and I have this same data set. So that's step 1 and 2. And now to run the Gaussian blur, all you have to do is search it in the search bar. And the search bar is actually the exact same search bar, more or less. It's got all the same functionality in the Fiji search bar, which Ed alluded to in his talk yesterday. So I can type, Gauss, and I'll see that there are some commands here, like some of these commands are the original ImageJ commands. I can see forum posts. This is, the point is this is all of the same stuff that you'll see in Fiji. And so in this script that we had written earlier, in step 3 here, I had run an op that had done a Gaussian blur. And so I can do the exact same thing here in napari ImageJ. I'll look for the one that passed just a single number for the sigma, as opposed to like a sigma for each dimension of the image, because ImageJ apps can do both. So if I make this a little bit bigger, unfortunately, I can't make this text bigger. But I'm looking for the one here that takes a number as the sigma, and I can click widget here, and now I have a nice Pythonic widget that I can use to enter in those same things that I entered in PyImageJ. So I have my input image here, which is taken from these napari layers. I have my sigma, which I think I had set to be 10. Yes, I had set it to be 10. And then these remaining parameters are optional, which is signified by these dashes. And I left them blank in the original script, so I'm going to leave them blank here as well. And I can click run, and you'll see in this activity pane, it was kind of loading a little bit, but then I did my Gaussian blur. And you can use this type of functionality to access anything from ImageJ ops. Anything from ImageJ ops works well in this little pane. A lot of the ImageJ2 commands that are scattered amongst this also work well in this manner. So that is kind of how you can run things in this napari ImageJ UI. So that's step 5. Yep. So if there are any questions on step 5, I'm happy to answer those. Otherwise, I'll move on to step 6. So Andrew asks, any way to add additional side Java plugins from the update site or manually to PyImageJ or napari ImageJ? That is a great question. So right now, the only functionality that exists is to add them manually, and you do that when you initialize the ImageJ. So you can see like this tab that's on pyimagej.net initialization. You can scroll down here. You can see that there is a tab for a specific side Java plugin. And all you do is, instead of just passing through a string, you can pass through a list of strings. So this one initializes with the latest version of ImageJ because there's no version specified. And then it also adds in Big Stitcher. So that's how you would do it. With PyImageJ, that's pretty clear. You can just do it when you initialize it like I'd done in those scripts. With napari ImageJ, you'll have to access it in the settings button, which I'm going to do in step 6. So stay tuned. When is it better to use PyImageJ to run scripts compared to running Fiji headless? that's going to kind of come down to well, there's two aspects. If you have PyImageJ installed, it might just be faster to run it with PyImageJ. Um, I mean, the main use case where it's going to be very helpful is if if you're trying to create a workflow that uses some Python tool as well as Fiji, right? Like maybe you've used Fiji for a long time, you've written a ton of scripts, but now there's some new Python tool out there and you're very excited to use it. But you don't want to rewrite your whole workflow, right? Sometimes you could, but it would just take a ton of time if there are things in Python that like if you can easily replace the Fiji code with Python things. But sometimes you just can't, right? If you have some niche thing in Fiji that only exists in Fiji and nowhere else, then your only option would be to like rewrite that code in Python, which would be horrible, be a huge, effort. And so that's when you would use PyImageJ. You would, you could write a script that would in Python. You write a Python script like we had done these earlier steps that maybe called your Python thing, right? Maybe you want to use something from scikit-image, or maybe there's a cool new algorithms library. So you call that thing, and then maybe that's pre-processing that runs into your your Fiji script. So you run your Python pre-processing, you convert your data then to Java, you do your normal routine in Fiji, and then you can get it back, right? So that's the real use case for PyImageJ is like unification, trying to use the best of both worlds, and also just portability. Hopefully that answers your question. Yeah, happy to be helpful. So okay, I guess if there are no further questions, I'll move on to step 6 here. So step 6 is just being able to run our script, right? So PyImageJ gives us a nice way to run the script, and napari ImageJ does the exact same. It provides you another opportunity to run your script, another environment to run your script. So not only can you run your script in Fiji, but you can also then run it in PyImageJ, and now you can run it in another UI in Python, which could be super powerful if you want to use your script in combination with a napari plugin. So, right, that's kind of the motivation here. And so there are a couple of steps that are required to get napari ImageJ to access to know where your plugin is. And so to do that, you have to first click on the settings button, which is this button here. And you need to set this Fiji Python 2024 directory to the ImageJ base directory settings. So that's what we'll do here. Click on the settings button. We'll find this ImageJ base directory. And I'm going to come here. I'm going to click choose directory. I'm going to make sure that it's this Fiji Python 2024 directory. And so what's going to happen here is that next time we start up an ImageJ2 instance, it's going to look in this directory for a scripts directory, right? So it's going to look for a scripts folder inside of this directory. And once it finds it, it'll load all of the scripts in here into our ImageJ2 instance. So then they'll appear in the search bar. So I can select this folder, and it looks like actually these settings had persisted from the last time I tried this. So it's not going to tell me to restart, but if this wasn't set before, usually it'll just be a dot. And if it's just a dot and you change it, then it'll say you need to restart Fiji because it has to restart ImageJ2. But it'll tell you to restart Fiji. So let's pretend that it told me to restart Fiji. So I would restart napari. So I'll restart napari. And when I restart napari, it'll boot up. And then I'll start up my napari ImageJ. And then I'll have all of my scripts loaded. And now it knows of our decon.groovy script. And so I've got my data set. I search for decon, which is the name of the script, right? Decon.groovy. So I search for decon. At decon, there's our script. I'll reload in the data that I had downloaded earlier. So here is our data set. I'll click on decon, And you'll see this is just a graphical view of those same script parameters that we saw in step 3, right? If I load up the script again, you'll see that that matches these script parameters, right? Here's our image, which we'll specify. This is the same as the napari layer, and all of these others are optional, right? They have default values which were loaded onto this widget. So I can click OK here, and it will start to compute. You'll see the activity pane is thinking here, and decon can take a minute, right? So it's kind of nice to be able to see this spinning down in the bottom, know that your script is running, and you can see it here in the progress bar. Unfortunately, this is just sitting at 33% until it's done, so it's not super helpful, but at least you know it's running. It's still computing, and then eventually the result will populate, and we'll see our deconvolved output here in the Napari viewer. And so while this is running, one more like nice benefit of Napari ImageJ is that we didn't have to call these translation functions that we had to call when we called it in a script. It's one benefit of the GUI. It takes care of calling these things for us, right? What it does is it looks for every parameter that was in your script. It calls ij.py.toJava on those guys directly. It passes all of those Java translated outputs into the script, runs the script, and then it calls from Java on the outputs and gives it back to you. So it's still thinking here, but it's kind of one step that you can avoid when you use the GUI. So it's just kind of trade-offs here, right? Running these things in the script allows you to do it headlessly, allows you to automate these things, but when you use it in this GUI with Napari ImageJ, it just works. There's no extra boilerplate code. So, you can see we got the same output. We got our background. We got our kind of denoised background here. We still have our structures that are a bit more visible. It's the exact same thing that we saw before, and that's kind of the point, right? You can take your script, you can run it in all of these new places, which opens the door to then, if you have a new Napari plugin that you want to pass, maybe you run this thing and then you want to pass the result off to some Napari plugin, now you can construct these things together. That's the benefit here. So that's step 6. And I kind of alluded to what step 7 is, which is kind of combining Napari plugins. But I'll take a quick minute for questions before I do this. Okay. Well, if there are questions, I'll stop and respond to them. But I'll get on to this last step. And unfortunately, I do need to throw out the disclaimer that this step doesn't work for those of you who are using Mac OS. And I've written up why, because it's kind of unfortunate. And the addendum one, which is right below this. But we are working on this. And it will be something that is hopefully available to you in not too distant future. But you can still watch how this works because it's very powerful. And this is, like I said, being able to combine Napari plugins, right? Being able to combine Napari ImageJ and everything that Fiji has to offer with any Napari plugin out there. So the example here is going to be TrackMate. So to run TrackMate, the first thing that you're going to have to do is make sure that you have Fiji installed, and we do this basically in the exact same way that we did with PyImageJ, where we specify the Fiji endpoint, right? We say we want Fiji version 2.15, and you do that here in the settings. You can specify it here. Like I said, I must have saved my configuration from an earlier run of this workshop. So I already have it entered in, but you would just kind of copy and paste this guy into this ImageJ directory or endpoint setting. And then you would click OK, and it would tell you to restart. So I'll pretend that it said OK. I'll restart my Napari. And when I restart my Napari, then it will go and re-download Fiji for me. In this case, it won't actually re-download Fiji. because we had already downloaded it for PyImageJ, but napari ImageJ will take, if needed, it will download the particular Fiji version for you. So it's kind of another nice utility that PyImageJ provides for you. But now we have Fiji, and which will allow us to run TrackMate. And actually, because we've got a very nice tutorial on napari.imagej.net, you can just follow this link to actually get to the instructions. So hopefully I can get through this in the last 10 minutes. But we'll download this TrackMate data. This is just like one of the example TrackMate data sets. And to start, we're going to get it open into the ImageJ UI. So you can start the ImageJ UI by pressing this button here. This button here starts the ImageJ UI. And now I have an ImageJ UI that is tethered to this napari instance. And so, if I have some data in napari, like let's say I had, actually I'll open a sample image. Open sample, brick. So I have the sample, I have this image in napari. I can transfer it to this tethered ImageJ instance by clicking this button, this right button that points to ImageJ. I click this button and bam, now it's in ImageJ and I can do ImageJ things with it. And, so then maybe I'll have some data, maybe I do something with it. I've got a different image that's in my ImageJ instance, and I can click the button that's going away from my ImageJ, and I can then it'll just go right back into napari, right? So these two this ImageJ instance is tethered to this napari instance, and I can transfer data between it to kind of get that same interoperability, like the interoperability that we want. Right, so here are those two things. So I'll get rid of these sample images and I'll open up this example tracking data. I'm going to open, I'm going to select this TrackMate example data that the use case wanted me to use. And so you can see I just have some cells and they move and maybe we're interested in how they're moving. So I'm going to move this a bit so I can read this. So I have my data. Now I just want to run TrackMate. So I'll run TrackMate by going to plugins. I'll go to tracking. I'll go to TrackMate, and this opens up TrackMate. And TrackMate, for those of you who haven't run TrackMate, it's kind of a wizard-based format where it'll walk you through the steps. And so I've got all of the steps listed here. Maybe this is a bit small, but unfortunately I can't increase the font size again. But the steps are all listed here, so I'd encourage you to come back to this document, which is linked from the workshop document, which hopefully everybody has a handle on at this point. So, this first window in TrackMate asks you to just confirm that you have the right image selected. You can also kind of specify which, maybe time points here you want to use. But this is all we don't need to make any changes here, so we can just click next. It'll ask you to select a detector so that it can select the objects in your image. These settings are fine, so I'll click next. We have to change a couple of settings here in the detector to make sure that it works, to make sure that it's looking for the right size of objects. And you can confirm this by clicking preview. So we selected 17 microns objects in size, and you can see that this did a pretty good job. I think the default is something smaller maybe, but I've done this before, so it remembers what I had said the last time. But all of these settings, again, specified here. So these, you want to make sure you have nice spots, and it'll just kind of go through and detect all of these spots across the image. Once the bar is finished, you click next. You can threshold your spots if you want, but we don't need to do that. So, here are all of our spots. And so then you can actually select a tracker for these spots. The basic tracker works fine for this data. Here are some settings that you can use to maybe specify branching, the starting of new tracks. These settings are also included in this particular walkthrough. So TrackMate's remembering these settings from the last time I ran this, but I click next. You can see here all of my tracks that are generated by TrackMate, and these spots move along the tracks, which is wonderful. And once I'm at this point, because this Fiji is tethered to this napari, I can just click this arrow, and my data will then go back into napari. And it takes a second, but here we go. Now we have a napari labels layer, which are all of the spots. We have a napari tracks layer, which are the tracks found by TrackMate. And then we have the original data set right underneath all of it. I just have the spots, right? So that's how you can kind of call napari or call Fiji behavior from napari ImageJ, which is super awesome. But it's not quite where this tutorial ends, because the end goal is to create this kind of unified workflow where we can then use a new napari plugin, or an additional napari plugin to kind of do something more, to gain more information. And so with this particular tutorial, we're using TrackMate in combination with the napari tracking plugin, or S-tracking plugin, which we can install. The installation instructions are here. We go to plugins, we go to install, and we look for napari tracking. I said that there was an error. Well, doesn't seem to seems to be a problem with my Fiji, or with my napari. Refresh. Seems to be an issue. Well, that's unfortunate. I'm not sure what the issue was with installing it, but if we can't, well, maybe I won't be able to show the actual thing working, but I can show you this GIF where I run napari tracking. So I guess I have the next best thing, and that I've already recorded this. So you can see that I still have the data here in napari, and then I open up the napari tracking plugin, and I can add some features that I want to observe for each track. It's unfortunate that I can't pause this, but I selected both the length feature, which tells me how many frames the track is present in across all of my Z stacks, and also the distance, which is how many pixels a particular spot moves, and I can click run afterwards, and I can see the data for each of my tracks. So that's kind of one very simple way of how you can use Napari ImageJ to combine some GUI features of Fiji and Napari into a single workflow. So I guess that's basically out of time. Luckily, I was the Napari snafu of not being able to install this was fixed by my GIF. But if anybody has any other questions, I mean, that's kind of all I had. So if there's anybody with any questions in the remaining 2 minutes, I'm happy to answer them. Otherwise, thank you for attending. I guess maybe I'll throw a shameless plug out there for the image.sc forum. This would be a great place to ask questions, in particular about some of Python interoperability things. I'm active here. The other Python Fiji devs are active here. So if you have any questions, maybe we don't have the time to answer here, or if there's, if you end up trying these things out and you encounter difficulties, post them here. We're happy to help. If you have any problems. Can ImageJ handle table outputs from SciJava parameters? I think so. That'd be a good question for Ed Evans. But I'm fairly certain that it can. Yes. Oh, yep. Ed responded yes. There you go. Yeah, and if it can't, then that's something that we should, fix, right? It's in a lot of cases, it's very difficult to, be able to make sure that PyImageJ can transfer every data structure well between the two. So and in some ways, it's kind of an ongoing effort to make sure that everything gets translated well. But if it doesn't, let us know, and we are happy to implement it. Cool. All right. In that case, I will end the meeting here. Thank you for everyone for attending.